Alright, welcome to another math tutorial video. This one is, of course, about the distance formula. This is one of the first things you're likely to learn in geometry, and you may have probably learned it previous to that as well. But I like to do it as a refresher right at the beginning of geometry. And the distance formula is a big, complex, long equation. A lot of my students are like, my goodness, that is so long, that is so difficult to remember. But once you actually start using it, it's really not that bad. It's not difficult or complex to use, just a long formula to remember. So let's go ahead and write the distance formula out. Now the distance formula is what I like to say, d, representing distance, of course, equals the square root of the quantity y2 minus y1 end quantity squared plus the quantity x2 minus x1 end quantity squared. Square root of over all of that, of course. So that is the distance formula. Pretty long equation to write out, right? But not that bad in reality. So let's go ahead and do a practice problem of this. So let's take 2 points. This is what the distance formula does. The distance formula allows you to take any 2 points. Let's say we have 3, 1, and let's go with 9, 11. We have any 2 points ever on a coordinate plane, and we can find the distance between them. Typically, if a line is straight or up and down or horizontal, vertical, it's pretty easy to find that distance. But whenever they go diagonal, that becomes significantly more difficult. So let's go ahead and talk about how to find the distance in between these 2 points. First thing you're always going to want to do whenever you have 2 points is label them. x1, y1, x2, y2. So that in our equation, we kind of keep things straight in line. Now I'm going to go ahead and write just above these the distance formula again so we can reference that. And it is the square root of the quantity y2 minus y1 squared plus the quantity x2 minus x1 squared. Of course, equals distance. So let's fill in our variables. I'm going to write the square root down. We'll start this with y2 minus y1. Now in this case, y2 is 11. y1 is 1. 11 minus 1 squared plus the next quantity, x2 minus x1, 9 minus 3 squared. Let's solve these. The stuff in the parentheses first, of course, order of operations kind of thing, right? Rewrite our square root. 11 minus 1, of course, just going to be 10 squared plus 9 minus 3, 6 squared. 10 squared is going to be 100. 6 squared, 36. We'll add those, and we get to the square root of 136. Simple as that. Now, you could solve this to get a decimal point. I mean, this is going to be somewhere like 11.7 or something like that, just estimating it. But in my own class, I don't mind if you leave it like this for now, the square root of 136. Later on, we are going to simplify that square root on a problem. We'll essentially just simplifying the radical. But for right now, I do not mind if we stick with just that answer. It is the square root of 136 units or centimeters or inches or feet, whatever we may be working with. So like I said, this is not a difficult process at all, in my own opinion. And most of my students agree with that. None of them have been having difficulty with this. Let's do one more example, though. One more example, and this time we will throw some negatives in there, right? My students hate negatives. Think it makes everything so complicated, but I like them. I don't know. They're okay. -4, 7, and then let's have another point at 3, -9. So, we're going to find the distance between these 2 points. Now we do have some negatives in there, makes things a little more complicated, but not too bad as long as you remember how negatives interact with positive numbers. So first off, we have y2 minus y1. Ooh, I forgot to label these. x1, y1, x2, y2. So we start with y2 minus y1. In this case, -9 minus 7. Then over here, plus x2 minus x1 3 minus negative 4 squared. And I forgot to write the squared there. So let's go ahead and solve this. Yet again, we want to do what's in parentheses first. Negative 9 minus 7. Now, of course, whenever you have a negative number and you subtract from it, you're just going farther down that ladder, right? You're digging a deeper hole. So we have negative 16 squared. Plus, right here, we have 3 minus negative 4. Now, what you're going to have whenever you do that minus negative 4, two negatives work together to create a positive, right? The way I always looked at it is just having this minus minus, two lines turning into a plus sign right across. Those two lines right next to each other. So 3 plus 4, 7 squared. Now we want to go ahead and square these numbers. Now you may at first be thinking, what the heck is 16 times 16? But that is in fact just going to be 256. I always like to know my squares right up to 15. So 16 gets right past that little level, and you always want to, I always want to double check myself, but it is 256. Another thing I like my students to remember, and just, it's easy to forget, whenever you have a negative squared, it does always turn positive. Negative 16 squared is not going to be negative 256, positive 256. Then 7 times 7, of course, is going to be 49. We add those together, and what do we get? Oh, gosh, let's see. That's going to be 305, right? But let me double check on my calculator. Yeah, I didn't want to embarrass myself by writing the wrong number down on my video. Yeah, it's the square root of 305. So that's how I'm fine with you leaving it on your answer, square root of 305, just like that. If you do have something that's like the square root of 16 as your answer, or the square root of 100, go ahead and simplify that down to the whole number. Of course, square root of 16, just write 4. Square root of 100, just write 10. I don't mind if you leave that like it is, though. So that's it for this video. If you have any questions, comments, or concerns, leave them down below, or check out my blog, mrmathclass.blogspot.com, and leave it there. If you'd like to see any more examples, feel free to ask. I will do just that. And thanks for watching. See you next time.